So आज chapter start कर रहे हैं about the amino acid titration curve. Okay. So why we are talking about the amino acid titration curve? Because there are various amino acids. We have already discussed about the amino acid, various type of amino acid, their role. Okay. I'm audible, Samya. Samya, can I introduce myself and then you can?
Yes, sir. Sir, I am an MSc student. I am a MSc student in Rourkela Autonomous College, and I am in first year now, sir.
Okay, very good. Your life sciences or biotechnology? What history you have selected?
No, sir. I'm zoology. Zoology. I am doing
Zoology, okay.
MSc in zoology.
Okay, so this class is regular from Monday to Friday and test will be on the Sunday. We have started unit 1. Okay, so for the classes there is no charge, but you have to pay for the test. Enrollment is must for continuing the classes and test. Okay, so we will discuss later on. If you are like the classes, you can talk to me and then we will discuss. Okay, thank you. So why we are talking about the amino acid titration curve, already we have discussed. There are two pKa. Have any idea about the pKa and pK2? I think already you might be knowing about the pK1 and pK2. So if you are not knowing, then I can revise. This is the general structure of amino acid, right? This is the general structure of amino acid. Okay. So what is the special about this amino acid structure? There are two functional group attached. One is giving the positive charge to amino acid and other is giving the negative charge to amino acid. So there are different R group and by which, are you comfortable in English or Hindi? Both languages are comfortable.
Sir, I'm comfortable in both the languages.
Okay. No. So this is the amino acid and whatever the property we are getting of amino acid, that you can observe only at physiological pH. So at physiological pH, there is a different behavior of ionization. For example, some amino acid has 2 carboxylic acid. Then what will be their behavior? And some amino acid, basic amino acid, you can say they are having the 2 amino group. Okay. So at physiological pH, we are titrating. That's why this is called as the titration. Different pH we are titrating and then getting the this kind of dipolar structure. And this dipolar structure is called as the, any idea? Zwitterion.
Zwitterion.
Right. So this zwitterion seems to be very simple, but this is not as simple because a lot of complexity is involved. Okay. So proceeding with the complexity, why they are complex and what are the non-ionic form. This is non-ionic form when there is no ionization of amino acids. Okay. And this is a zwitterion form, zwitterionic form when there is a perfect ionization. Okay. And so if you're talking about various kind of amino acid, already we have discussed that the central carbon attached to amino acids are chiral center. Okay. So except the glycine, almost all amino acids are active or kind of chiral centers. Okay. And rest of the amino acids is having the different, all 4 group are different. That's why they are the chiral group. Okay. So there are 2 forms existing, L form and D form. Okay. So there are 2 forms, L form and D form. So L form is most common form which is found in the body, and that's why we are going to discuss about the L form action at the physiological pH. Okay. So now next. So glycine is optically, that's why optically inactive. I have discussed why this is optically inactive. Because why glycine is optically inactive?
Because it has hydrogen in the R group.
Yes, and that's why 2 hydrogen are there, and that's why this is not a chiral group. Okay, not having the chiral center. That's why they are optically inactive. This is a single amino acid which is optically inactive. Rest all are optically active. So cysteine are specific in having the SS group. Yesterday we have discussed the histidine R group may be proton donor or acceptor at physiological pH. So next notebook रखे रहना है ना. So already we have discussed about the non-polar and you must remember the abbreviated form. For example, glycine G, alanine A, proline P, valine V, leucine L, isoleucine I, okay, methionine M. So sometimes you may get confused when there is a similar form or similar first alphabet, okay. तो कई बार confusion होता है. So you must remember the structure as well and especially the R group because every amino acid is different in the R group. For example, alanine having the methyl group, proline, valine, iso group, okay, methionine, S group, sulfur group is there, okay. You can see S group. This is the iso group. Isoleucine. You can see the different structure. Leucine again iso group, isobutyl group. Okay, so you must have a very good chemistry background. Then it will help you in understanding their behavior. Though I will try to make it clear what are the different aspects, right? So what are the different aromatic amino acids? There are three different aromatic amino acids: phenylalanine, tyrosine, and tryptophan. Tryptophan is called as W in abbreviated form. Tyrosine Y, phenylalanine F. All these are hydrophobic. Why? Can you tell me the reason? Can you tell me
Sir,
the
I
reason?
have no idea about it.
Hmm? No
Sir, I
idea.
don't know the reason. No.
Hydrophobic means they are not dissolved in water. Okay. That's why phobic. Phobic means phobia. कहते हैं ना phobia है इसको किसी चीज से. Okay. So what is the phobia? Phobia किस चीज से होगा? So there are two terms. Hydrophobic. Hydro means water. Okay. Phobic means repelling factor. Away. So if anything, that is a non-polar. So non-polar will be hydrophobic. Okay. And if anything dissolve in water, then what you will say? What the term you will use?
Hydrophilic.
Hydrophilic. Why you are saying the hydrophilic?
Hydro means water and philic means loving, I think.
Okay.
Attracting.
Yes, attractive. So on the polar group, having charge group. Okay. So polar amino acid will be they will be called as hydrophilic. Means they are water soluble. Okay. Water soluble. So CS3 is the aliphatic group. CS3 is polar or non-polar. This is non-polar. But if I am attaching any functional group like CS3H, so they will be polar. So if they are polar, then what you can say? They are polar, they will be dissolving water. Dissolving water, right? And if they are non-polar, only a little bit modification you can see. Addition of hydroxyl group, carboxyl group, any charge group if they are attached, they will be making it polar. Similarly, the benzene ring. Benzene ring is polar or non-polar? Benzene ring is polar or non-polar? Tell me.
Non-polar.
Non-polar. So that's why anywhere in the R group, if this is attached, they making them non-polar and they are called as hydrophobic. So this is the one criteria deciding on hydrophilic and hydrophobic. Okay, clear?
Yes,
So
sir.
that's why you can see this phenylalanine, tyrosine, tryptophan, they are hydrophobic. Okay, you can say the hydroxyl group is there, they must be dissolved, but they are sparingly dissolved, means they are very solubility is very low in water. As soon as you are increasing the function group, they may be more soluble. There are other polar uncharged R groups like serine, threonine, cysteine, asparagine, and glutamine. Glutamine is written by abbreviated form Q. You remember Q written, it means glutamine. Asparagine, not A. This is N. Cysteine, C. Threonine, T. Serine, S. ठीक है? Is it clear? Can I proceed? So these are the polar or non-polar. Just tell me. Serine is polar or non-polar?
Polar.
It's polar because of presence of OH group.
OH group.
OH. है ना? Threonine is polar or non-polar? Jayaprakash? Ananya?
Sir, polar.
Yes. Because here you can see the OH group. And what about the cysteine? This is polar or non-polar?
Cysteine.
If it dissolves in water, if it dissolves in water, then again it gains negative charge. So that's why this is polar. Okay. What about the asparagine? This is polar or non polar?
Polar.
This is polar. Why? Because CO group is attached and oxygen is much electronegative. They can put the electron of carbon and that's why H2N become gaining the positive charge. Okay. So it's all about the power. Oxygen is more powerful. That's why they are pulling the electron from here, pulling the electron from here. So this kind of structure is called as the dipolar. Okay. So they are creating the polarity. Dipole, dipole. Have you heard about dipole moment? Dipole. Dipole means when there is a strong electronegative charge, electronegative element are there, for example, oxygen, phosphorus, sulfur, they are pulling the electron forcibly from the carbon and if any group is attached to the carbon, also their electron is pulled in this direction, right? But suppose oxygen in the center, for example, in the water, so they are pulling the electron toward the oxygen, right? So this is also a kind of dipole. Similarly, glutamine is polar. Okay, so I think we have a very good concept of polar versus non-polar because then you will be able to solve problem like water solubility, which protein is going to be soluble, which protein is going to be hydrophobic. A lot of questions based on this information is going to be asked. And what about the lysine? Lysine. First, you should know the lysine is written in the abbreviated form like K, histidine H, arginine R. So LHA, these are the polar amino acids. Why they are polar? Can you tell me? Why this is polar? This is polar. They have none the OH. No OH group in here. Only the amino group is there. Tell me. Hmm? Why they are polar? Any idea to anyone? Jayprakash, Ananya, Samya. Obviously, they are
Sir,
the amine group.
due there is charge at the NH3 group, I think that's why.
Yes. At physiological pH, they are gaining the charge. And if any molecule that is charged is attached, they will be the polar, right? If suppose I am removing this NH3, okay, so they are not going to be polar, they will be non-polar. This will be the non-polar without NH3, without NH3 positive. But tell me why histidine is polar. Tell me. There is no NH plus. And this is I would like to share you a beautiful information about the histidine. Uh, Histidine is both proton acceptor as well as donor. This is both acting as a donor as well as acceptor. Okay, got the idea? But you will tell me tomorrow, write the homework, why histidine is polar. So they don't have any kind of positive charge over the NH2. And why they
So
are
due
both
to
polar?
imad ring, this.
Due to ring, what happens? Very good.
So ड्यू टू मतलब इस रिंग की वजह से शायद ये पोलर है.
होता क्या है ना, रेजोनेटिंग स्ट्रक्चर देख रहे हो ना? Have you
हाँ
heard
जी.
about the resonating structure? This is the resonating structure and CH is attached here. H is attached here. So they are both pulling the electron from the H, making it positive. Okay. So though NH is present in the ring, right? So nitrogen is also a very high electronegative group. And oxygen, fluorine, nitrogen, all they are of having very high electronegativity. So that's why. So they are able to pull because of the resonating structure. Clear? Any doubt? ठीक है?
Yes, sir.
What happens, Soumya, Ananya? Is it okay?
Yes, sir. I have no doubt. Yes, sir.
Okay. So what you can see, the next one is aspartate and glutamate. So they are having the carboxyl group, which are negative, having the negative charge of physiological pH. Okay. So again, aspartate and glutamate. Aspartate is written as D. If anywhere in the protein structure D is written, you will assume it as a aspartate. If E is written, it will be written as glutamate. ठीक है? ठीक है?
Yes,
शॉर्ट
sir.
फॉर्म भी याद करना है
Yes.
अच्छे से. ठीक है? What about the cysteine? This is a very hot topic. Many times it has been asked in the examination. There is a difference between the cysteine EIN having the SH group. And if they are joining, the E is removed. Okay, can you see the difference? This is the difference between the cysteine and cysteine. So after the removal of two proton, you can see this linked structure. This linked structure is very useful in the protein biochemistry. Why? Because, tell me, any idea? Any guess? Hmm? No idea? Do you know about the what I'm saying, antibody structure? Have you heard about the antibody structure? Antibody, you know?
Yes, so disulfide bonds are between a heavy chain.
Yes. So you can see the three-dimensional structure of this antibody. This is a 3D shape, and 3D shape is stable because of S group, disulfide group. Okay, this is SS group, disulfide group. Okay, if you are removing this disulfide group, their 3D shape will be lost. Why they are lost? Because this is the covalent bond between the SS group and they are maintaining the 3D structure, and if they are disturbed, so obviously what will be lost? 3D structure will be lost. Similarly, wool. Do you know about the wool? wool के बारे में तो सुना ही होगा. Wool, you know?
Yes, sir.
So what is the special feature of the wool? What is the special feature of the wool? wool, अरे चलो हेयर की बात कर लो अपने. अगर तुम्हारे हेयर में वो लड़कियां गर्ल्स कराती हैं बाल को स्ट्रेट, ठीक है, आप भी कराते होगे, तो बाल तो कर्ली होते हैं, ऐसे होते हैं, लेकिन वो स्ट्रेट कैसे होते हैं? दिस इज अ वेरी गुड बायोकेमिस्ट्री इफ यू वांट टू अंडरस्टैंड.
वो सर हीट देते हैं, हीट
हाँ,
से
हीट देते हैं तो व्हाट हैपेंस, हाइड्रोजन बॉन्डिंग की वजह से जो कर्ली शेप आ रहा है तो हाइड्रोजन बॉन्ड सारे ब्रेक हो जाते हैं. लेकिन अगर आप सीधे सीधे आग लगा दो, फायर कर दो, तो ये यहाँ से सही
ब्रेक हो
है ना, ब्रेक होना शुरू हो जाता है, बिल्कुल ये खत्म हो जाता है. तो हाइड्रोजन बॉन्ड वर्सेस डाइसल्फाइड, दीज आर द टू स्ट्रक्चर दैट आर मेंटेनिंग द हेयर शेप और वूल शेप, है ना. वूल देखो कितनी जल्दी, अगर हार्श केमिकल डाल दिया वॉशिंग मशीन में, है ना, तो वो भी खराब हो जाते हैं, श्रिंक कर जाते हैं काफी ज्यादा, एंड दे आर नॉट गोइंग टू बी स्ट्रेट बिकॉज यू आर डैमेजिंग द एसएस बॉन्ड. एसएस बॉन्ड एक बार ब्रेक हो गया तो इट्स अ वेरी डिफिकल्ट टू रीगेन. इज इट क्लियर?
यस सर.
Yes, sir.
This is the role of disulfide bond. So cysteine and cysteine. Now you might be knowing the difference between two. Reactive SH group of cysteine oxidizes into the disulfide bond, and this is the reason they are impacting the 3D structure of the protein. Now we will talk about the amino acid titration curve. What is amino acid titration curve? When you are plotting a titration curve, when you are trying constructing a titration curve for each amino acid separately, right? So what you are doing, you are adding hydroxyl group and you are measuring the change in pH. Okay, titration तो किया होगा ना लैब में, आप देखते हो ना कलर आता है, आप कोई केमिकल डालते हो तो जैसे कलर आता है you stop adding the chemicals, है ना. तो आप पीएच ही तो चेंज कर रहे हो, जो भी आप केमिकल डालते हो, ओएच डालते हो या एचसीएल डालते हो, डाला है कभी लैब में?
Yes, sir.
Yes,
यस
sir.
सर. 10+2 में एक बार किया.
हाँ, ठीक है ना. तो ऐसे टाइट्रेशन होता है. So what you can do, you can add the hydroxyl group for amino acid and you can change the, you can see the change in pH and you can plot hydroxyl added on the x-axis and pH on y-axis. I can show you the diagram. Right? Now you can see this is the structure of what? Titration curve of amino acid glycine. ये बड़ा पूछा जाता है एग्जाम, इसके हाल से पूछी जाती है, ठीक है। तो नाउ अंडरस्टैंड दिस कॉन्सेप्ट फ्रॉम हियर। तो एक्चुअली में ग्लाइसिन में यू कैन सी देयर आर 2 H ग्रुप, ओके। R ग्रुप भी है ना, R की जगह H है, और जो नेचुरल H है वो तो है, ये बाद में क्या है, कार्बोक्सिल ग्रुप है, अमीन ग्रुप है, ठीक है ना। तो ये 2 H हो गए। तो हाउ दे विल बिहेव व्हेन यू आर एडिंग द हाइड्रोक्सिल इक्विवेलेंट। So now you can see there are 2 pK value, pK1 and pK2. So as soon as you are increasing the hydroxyl group, you are getting the first pK1, and at this pK1 अभी अगर डिस्कनेक्ट होता है जूम तो ज्वाइन कर लेना। वैसे मैं होस्ट बना रहा हूँ जयप्रकाश को, राइट, सो दैट मीटिंग शुड नॉट कैंसिल, मीटिंग विल बी कंटिन्यूअस, ठीक है जयप्रकाश?
Yes, sir.
हाँ, ओके।
Yes, sir.
Continues. So we are talking about the titration curve of glycine. What you can see here, you can see the two value, pK1 as well as pK2. So pK1 and there is a lower pH. Okay, तो जब lower pH है तो क्या देख पा रहे हो आप? What you can see here, positive charge. Okay, positive charge. Sorry, positive charge is there. Negative charge you can see additional. That is the difference from the this one. Okay. So when there is a lower pH, the carboxyl group ionizes to CO minus. Okay, and then at the more OH when you are adding, then you are getting the pK2, and now what you can see, the charge over the NH2 becomes disappears. Okay, ये गायब हो गया, ठीक है ना। So that's why there is a 2 pK1 value, pK2 value, and what is the PI? PI is the isoelectric point, and if you have a 2 pK1 plus pK2, then you can get the isoelectric point, the mid of the this titration curve, ठीक है ना। ये बीच में आपको मिलेगा, ठीक है ना। 0 से 13 pH तक का ये किया गया है ना, हाइड्रोक्सिल इक्विवेलेंट पीएच एट अराउंड 2 स्टार्टिंग फ्रॉम द। तो अगर इसको एवरेज करोगे तो व्हाट यू कैन गेट 9.6 upon 2, you are getting around 5.97. That is the isoelectric point. Okay. So when pH is equal to PI, what is the definition of isoelectric point? When the pH becomes equivalent to isoelectric point. This is, sorry, pH equivalent to pK. No? So then you can see there's no movement, and amino acid is going to stop, and this point is called as the isoelectric point. Isoelectric point means this is the isoelectric point. By the equation you can understand this is the isoelectric point, right? When both the charges are there. Okay, so this is also called as the zwitterion, this is also called as the dipolar ion, right? And if you are trying to get the gel electrophorese, so in which direction they are going to move? There are two ends in gel electrophorese, positive as well as negative. So your amino acid is somewhere here. Okay, so this direction move करेगा. Tell me, this is the isoelectric point. Tell me in which direction they can move. सौम्या, अनन्या, जयप्रकाश.
Sir,
ये मूव ही नहीं करेगा क्योंकि इक्विवेलेंट चार्ज है ना.
हाँ इक्विवेलेंट।
जैसे नेगेटिव चार्ज अकेला रहता तो वो पॉजिटिव की तरफ मूव करता है, पॉजिटिव चार्ज अकेला रहता तो वो नेगेटिव की तरफ मूव करता, लेकिन दोनों चार्ज है तो दोनों चार्ज कब आए, व्हेन पीके इज इक्वल टू पीआई, पीके इज इक्वल टू पीआई, तो देयर इज नो मूवमेंट ऑफ ग्लिटर आयन, लिख लो कॉपी में।
तब तो सर इसकी बैंड नहीं बनेगा इसका।
जब मूव ही नहीं किया तो कौन सा बैंड, जहां था वहीं पे है,
यस सर।
ठीक है ना। तो दिस इज द टाइट्रेशन कर्व फॉर ग्लाइसिन, जो कि सबसे बेस है। आपको अगर टाइट्रेशन समझना है, बहुत सारे क्योंकि कॉम्प्लेक्स अमीनो एसिड भी है, एरोमेटिक भी है ना, तो उनका अगर समझना है तो यू नीड टू अंडरस्टैंड दिस वन फर्स्ट, ठीक है, क्लियर। If you have any question and doubt, you can ask. No? No. So you can see there is a 2 pK value. pK1 is less than pK2. Okay. So first proton is released from one acid is much more easily given up than second proton. And second pK, there are two regions of buffering capacity. Okay. That's why third pK you can obtain when there is a ionizable group, like glycine is there, arginine is there, histidine is there, okay. So maximum amino acid having the how much pK value? pKa1, pKa2, okay, and sometimes they also have the pKa3. When pK3 is possible, when R group is having ionizable,
आई नो जबल।
तो याद रहेगा ये,
यस सर।
है ना, नोट कर लो क्योंकि ये चीजें नहीं मिलेगी, ठीक है ना। द थर्ड pKa will arise when R will be the having the ionizable amino acid, ठीक है।
यस
सर बफरिंग कैपेसिटी का मतलब क्या है?
बफर जैसे आपको बता दूं, in the blood system we are respiring CO2, so CO2 is not buffer, but when they are mixing with the H2O, they are forming the H2CO3. Now this becomes the salt, right? समझ रहे हो? Salt हो गया, तो when you are dissolving them into the water, so they show ionization like H plus and SO3 minus, ठीक है ना। तो buffering capacity मतलब when they will be, you are raising or changing the pH, then they are neutralizing that change in the pH. They are maintaining the same pH. That's why they are called like the buffer. Or buffering capacity means capacity to resist any change in the pH. That's why we are using the term buffering capacity in the region 2. Why? Because first region proton is easily released from amino acid and easily given up, while in the second proton is not easy. It's a resisting the change. Okay. So that's why we can use the term buffering capacity. Clear? बफर का मतलब जानते हो ना,
Yes.
बफर अगर डाल दिए, जैसे मान लो आप कोई एक्सपेरिमेंट कर रहे हो एनिमल टिश्यू के साथ, तो कहते हैं भाई पानी में करोगे तो ऑस्मोटिक डिसबैलेंस हो जाएगा और ये डेथ हो जाएगी सेल की, तो क्या करते हैं यूज बफर। आप डीएनए आइसोलेट कर रहे हो, डीएनए आइसोलेट करने के पहले आपको कहते हैं भाई फॉस्फेट बफर डाल दो इसमें, use the buffer. Why we are using the buffer? Because if they are not using the buffer, they are going to change the overall structure of DNA, and even they can be denature about the amino acid. तो ये क्लियर हो गया why there is a 2 pK1 pK2 and about the pK3, ठीक है ना।
यस सर।
Now the next one. So now you can understand the biochemistry here by the reaction. Okay. So what is shown here? This is a glycine. Glycine. Okay. So this is the pK value, pK1, pKa1. So what you can see here, there is a ionization of carboxyl group. Okay. So why there is a ionization of carboxyl group at low pH? Because you are adding the hydroxyl equivalent. Okay. So hydroxyl, what they are doing, pulling the प्रोटॉन, यहाँ से प्रोटॉन पुल कर लेगा, ठीक है ना। तो प्रोटॉन चला गया, जब प्रोटॉन चला गया हाइड्रोक्सिल के द्वारा तो ये यहाँ पे चार्ज आ गया माइनस। इज इट क्लियर? क्लियर टू ऑल ऑफ यू?
यस सर।
ठीक है ना?
Yes, sir.
ओके। सो अब देखो यहाँ पे सेकेंड पीके में व्हाट इज हैपनिंग, ऑलरेडी यू कैन सी द मोर हाइड्रोक्सिल ग्रुप यू आर एडिंग। तो हाइड्रोक्सिल ग्रुप जब ज्यादा ऐड कर रहे हो तो इसने अब यहाँ से स्टार्ट करना, क्योंकि और तो कोई बचा नहीं जिससे वो पुल कर सके। तो नाउ व्हेन दे आर विथड्राइंग द एक्स्ट्रा H over the NH3, it becomes NH2. Okay, the electronegative oxygen atom in the carboxyl group pull electrons away from the amino group, lowering its pKa. Okay, तो इसने pKa को और डाउन कर दिया। So that's why at the second pKa it's very difficult to pull the proton, because proton is not available. All the buffering capacity depends on pulling of the protons. Proton available नहीं है तो कहाँ से वो pull करेगा? That's why at pKa2 this acting as a buffering capacity. ठीक है? Clear?
यस सर।
Any doubt?
नो।
Now, what about the glutamate? Glutamate has the pK1, pKr, and pK2. Okay. So now you can see the structure of glutamate. Then what you can see here, this is the same. Okay. Now there will be change here first. कहाँ पे चेंज आ रहा है? यहाँ पे, ठीक है। ये देखो चेंज हो रहा है, राइट। तो वंस एट लोअर पीके द प्रोटॉन गॉन, प्रोटॉन इज पुल्ड बाय द हाइड्रोक्सिल इक्विवेलेंट। ओके, इट गिविंग द फर्स्ट pK1। ओके, अब जब सेकेंड फिर और ज्यादा हाइड्रोक्सिल डाला तो सेकेंड प्रोटॉन वाज पुल्ड फ्रॉम हियर, दिस बिकम्स pKr, है ना। अब नाउ थर्ड यानी pK2 is arising because of more pulling of proton from this group. So you are getting this one, neutral. Sometimes they can ask with the structure, pK1 structure, what you can see, this type of structure. Sorry, this type of structure you can see. Okay, at pK1. And they can sometimes ask you what is the structure at pK2.
तो
अभी क्लियर हो गया ना? चार्ज देख लेना, जैसे डबल कार्बोक्सिल ग्रुप अटैच है तो ऑब्वियसली देयर विल बी pK1, pK2, pK3। इसको ऐसे भी बोल सकते हो, या pK1, pKr, pK2 एज यू विश, राइट।
यस।
Yes, sir.
ठीक है ना। तो दिस इज ओवरऑल pK इन द अमाइनो एसिड व्हिच आर हैविंग मोर फंक्शन। जैसे ये एसिडिक है, ग्लूटामेट इज एसिडिक बिकॉज ऑफ 2 कार्बोक्सिल, दैट्स व्हाई दे आर गिविंग द 3 pK। ठीक है, तो इस पे चार्ज कैलकुलेट करने के लिए आपको ये रिएक्शन याद रहना चाहिए, बिकॉज समटाइम दे आर आस्किंग कि व्हाट विल बी द ओवरऑल चार्ज एट pK2। ओवरऑल चार्ज यहाँ पे क्या है, पॉजिटिव है या नेगेटिव है? टेल मी, ओवरऑल चार्ज क्या रहता है?
नेगेटिव।
Negative.
याद रहेगा ना, मोस्ट ऑफ द अमीनो एसिड का दिस इज अ कॉमन बिहेवियर कि एट हायर pK they are having the negative charges। अगर वो एसिडिक अमाइनो एसिड है। अगर बेसिक होता तो थोड़ा अपोजिट होता, ठीक है। एसिडिक अमाइनो एसिड के लिए नोट कर लो। फॉर एग्जाम्पल ग्लूटामेट, ग्लूटामेट के लिए क्या बोलोगे? एट pK1 there will be neutral, pK1 पे न्यूट्रल है ना, while at
Yes,
pK2
sir.
there will be negative,
Negative.
not positive, है ना, positive negative. This is the small things but very useful, because once you understand the amino acid characteristic, you can cover up many physiological phenomena like cancer and ovulation and developmental biology, microbiology, everything is connected with this protein folding, protein biochemistry, metagenomics, proteomics. Okay, so everything. If you have any doubt or any requirement, you want a specific lecture over any topic, you can suggest me also. Okay,
No, sir.
because you have to qualify the JRF, so this is very good idea to join at this stage. And this is first year, I think this is the best, because you can not only improve your CSIR score, also you can improve your score in the current examination. Okay. And if you want to study about your current curricula, any topic on the cancer or any, whatever the syllabus I have been prescribed. So if you have any problem, you can discuss me. You can plan that lecture. Okay. So you can study. So, I think tomorrow we are going to study the peptide, the naming of the peptide bond. Obviously, कल का होमवर्क रहेगा कि आपको सारे शॉर्ट फॉर्म याद होने चाहिए। याद करके आओगे हमारे से सारे फॉर्म, शॉर्ट फॉर्म?
Yes. Yes, sir.
Yes, sir.
मैं से शेयर कर दे रहा हूँ आपके ग्रुप में, दैट विल बी
Yes.
हेल्पफुल टू यू, ठीक है। और रिवाइंड करा देना, यू कैन दैट। चलिए चला गया ग्रुप में। So motivate all of your friends, because there is no charge of the classes, right? So they can enroll whenever,
Yes.
after 1 week of the demo classes, they can enroll. And already many professional coaching are charging from 13,000 to 26,000 of the same classes. Okay. So we are not charging that. We are charging 3,000 for test and 3,000 for enrollment, 26,000 for 1 year. We can discuss all the 13 topics. We are not committing to in 6 months I will do the magic. So I'm not in a hurry, because CSR is not the one-day game. It's a long-term goal. Okay. So a lot of tests will be conducted, and those will be appearing in the test who are enrolling themselves. So with this, I hope the future will be bright and you will be motivated to learn a lot of things. So we are going to learn a lot of things about the protein, starting from the peptide now. And also we will discuss tomorrow about the charge over the amino acid, how the charge is calculated of bitter ions or kind of proteins, right? So protein structure is given and they are going to ask you the charge, acidic pH, what is the charge, and what is the charge at basic pH, though we have discussed it today. But we will discuss. I want to motivate you more, because if motivation will be high, the brain is going to learn at high value. Okay. So motivation factors will be very high. You should not be demotivated yourself by any kind of thought or any kind of negativeness. Always struggle will be there in the life, right? And nothing is the best unless your effort is best. Okay. So with
Yes,
this,
sir.
I'm ending my lecture. Always be motivated and never feel low. है ना कि आप कमजोर हो किसी से, नहीं कभी, ठीक है ना। नो वन इज पर्सन आर ऑफ टू टाइप, या तो वो वीक होता है या तो इंटेलिजेंट होता है, ना तो कोई सुपर इंटेलिजेंट है, ना कोई जीनियस होता है. दिस इज ऑल false categories. Okay, all we have the same kind of neurons in the brain. It's why we are differing from each other. So we are differing from each other only because of lack of motivation or highly motivation. If you are highly motivated, we can do the wonders. Right? कभी भी किसी को देख के कंपेयर नहीं करना. ठीक है? Nothing is best in the world. Teacher is always same. Everywhere you go, teacher be same. But teacher has a more experience that will give you the better idea. क्यों? जैसे अगर हार्ट सर्जरी किसी ने सीखा है, ठीक है, और उसके पास जाते हो तो उसका 50-50 चांस है बचने का. ठीक है ना. लेकिन अगर कोई एक्सपर्ट है 20 साल का हार्ट सर्जरी में, तो लोग कहाँ प्रेफर करते हैं? जो अभी भी सीखा है सर्जरी या जो ऑलरेडी काफी एक्सपीरियंस वाला बंदा है? कहाँ जाते हैं? चलिए
एक्सपीरियंस वाले.
एक्सपीरियंस वाले के पास, क्योंकि आपकी सेफ्टी होती है. मोस्ट ऑफ द कोचिंग आर name is professional, but they are doing the unprofessional thing because most of the students are teaching there by reading the books. Because if they don't have any experience, na, so they are just misguiding you. Sometimes they are telling you the wrong things also, and you will not be able to see that things. ठीक है ना? Always be safe. Always plan your study. Every day we are going to apply this session at 7 p.m. to 8 p.m. And I expect you to study a lot. है ना? Stick to the framework, stick to the syllabus, and make your notes. Always I'm giving the homework, so come with the homework. No? It should be completed because then only you are continuing with your learnings. Because if you are missing the lectures or you are not doing the homework, it means you are not getting connected with the topic, and in the end, what will happen? What will happen? You will miss all the things and you are not going to gain anything. Because test itself is a reflection of your learning. ठीक है ना? तो टेस्ट में हमेशा पार्टिसिपेट करो. एंड माइनर इशू है उसको भूल जाओ. किसी ने कुछ बोल दिया, किसी ने कुछ डिमोटिवेट कर दिया, क्लास अच्छी नहीं है, ये आपके मन का नहीं हुआ, ऑल दिस फैक्टर्स आर डिमोटिवेटिंग. कभी भी डिमोटिवेट नहीं होना किसी फैक्टर से, बिकॉज योर ब्रेन इज सुप्रीम. तब कैसे लोग डिस्कवरी करते थे? जब कोई इंस्ट्रूमेंट नहीं होते थे, कोई फैसिलिटी नहीं होती थी, कोई टीचर नहीं होता था, तब भी डिस्कवरी होती थी. आज से 17 साल पहले. ठीक है ना? डू यू एग्री? तुमने अनन्या?
Yes, sir.
फील एज ए डिस्कवरर, मेक ए पावरफुल ऑब्जर्वेशन ऑफ एवरीथिंग. क्योंकि किताब में जो लिखा है वो किसी का ऑब्जर्वेशन होगा, फिर किसी ने प्रूफ किया उसको. तो आप भी बहुत विजिलेंट रहो, ऑब्जर्व करो चीजों को. जैसे अभी घटना हुई है ब्राजील में. देयर इज ए केस ऑफ ट्विंस वेयर बोथ द बेबीज आर डिफरेंट फ्रॉम द डिफरेंट पेरेंट्स. तो यू शुड बी क्यूरियस.
यस सर, यस सर, यस सर.
ये कैसे हुआ? एक ही टाइम पे बेबी पैदा होता है एंड दे आर फ्रॉम द डिफरेंट बायोलॉजिकल. तो चलो इन सबके साथ एंड करते हैं लेक्चर को. And if you have any question, you remain connected on WhatsApp. Thank you so much.
Okay, thank you, sir.